Hi everyone, welcome back. In this series of lectures, we are going to cover optimal binary search tree, where we are going to look at what optimal binary search trees are, and then we are going to derive its recurrence. And finally, we are going to look at an example where we solve one of the problems for a better understanding and hands-on on the algorithm. So in this lecture, we are going to look at the problem definition. Okay, so before going into that, I hope you know what a binary search tree is. A binary search tree is where we have a root and everything on the left is less than root and everything on the right is greater than root. Okay, this is a binary search tree. So for example, this is a binary search tree. 2 is the root and on its left everything is smaller than 2 and on its right everything is greater than 2. Okay, now let's move on. If you remember your previous lectures, searching in a binary tree takes log n, which is its best or average case, and this complexity comes when a binary search tree is balanced. So a balanced binary search tree, something like this. So if we want to find this node from root, this is going to take log n time complexity. Okay, so this is some of the basics of the binary search tree. Now let's say the items which are coming are not evenly distributed, which means, let's say we have the same 3 items, 1, 2 and 3, and the probability of these 3 items is 80, 10 and 10. Now if we are going to do the same balanced binary tree, the total operations we are going to do is, the probability of this is 0.8 and the search time is 1, because when we start our search, in one operation we are going to find 2. For 1, the probability is 1.1 and we are going to find it in 2 operations. Similarly, for 3, the probability is 0.1 and we are going to find it in 2 operations. So if we are to find 3, we start from 2, we see 3 is greater than 2, so we go on to the right and we find 3, which is 2 operations, and this is going to give us 1.9. Let's say we create another tree which is something like this. This is not balanced, but let's see. So probability of 8 coming is 0.8 and its search time is 1. Probability of 2 is 0.1 and we take 2 operations to find 2, and probability of 3 is 0.1 and we are going to do 3 operations to find 3. So then the total is 1.3. So you see, depending on the frequencies of items, it can take less even if when the tree is not balanced. And when the tree is balanced, it might take longer than a unbalanced tree. And this is the whole idea of optimal binary trees. So we see that a balanced tree, depending on the frequencies of items, might not be optimal. Okay. So then if we define the problem, we say that we have items one to n with their probabilities P1, P2, P3 and Pn. Okay. And then we need to find a tree which is most optimal. That means we need to find what is going to be the root of out of these items, and then we keep on going and finding the subtrees in the primary tree so that we create a optimal tree. So if we see that we want to find the total cost as we did above, here the total cost came out 1.9 and here the total cost came out to be 1.3 for this tree. Okay, so then what would be the formula for finding the cost in a tree? Which will be, if we have items 1 to n, then we are going to sum the probability into search time of I in T, right? That's what we did. Probability of 1, search time of 1. Probability of 2, search time of 2. Probability of 3, probability of 3 and search time of 3, right? So this is the same formula. Or what we can say is cost of T is summation of I to n all the probabilities and depth of I plus 1, right? So if we go above, the depth is 0, depth is 1, depth is 2. So then depth plus 1 is 1, which is the total search time. This is depth is 1 plus 1 equal to 2, that is the search time. Depth is 2 plus 1 is equal to 3, that is the search time. So then we converted it into a depth. So this is the basic idea of optimal binary search tree, where we try to find an optimal tree based on the frequencies or the probabilities of the items which are coming. I'm going to end this session here and going to see in our next lecture on optimal binary search trees, where we are going to derive the recurrence and the main formula which is going to help us in solving the optimal binary search tree problems. So I'm going to see you in our next session. Bye for now and thanks for watching.